Hey everybody, Mr. Fortin here. Now, I know we're having kind of a not really rushed unit. I mean, I think it's going to be fine. You're going to see what you need to see for area and volume. But one thing that I'm not really doing this year, not really required of you, is kind of proving the different area and volume formulas. I mean, we'll kind of look at some logic around why these formulas are the way they are. But in a normal year, we'd explain where they came from, right? And you might be wondering that this year, where do these formulas came from? So anyways, I'm filming a series of videos that are going to be optional that are just going to explain where each one of these formulas come from. First thing up is area of a square. Now, I know you heard me explain in class, we already put it in the toolkit here, but just because I'm not requiring you to read the textbook, I just want you to know the area of the square, that's our foundational assumption. Foundational assumption for how area works, and that is in terms of square units, right? How much a square can take on the inside here, okay? So area of a square, very simply, is the formula area equals s squared, where s is, of course, a side length. Okay, because a square has all equal sides, 4 equal sides here, okay? So can't be proven, but it's pretty darn obvious, okay? And you can see that on grid paper. Of course, if I have a 1 by 1 square, how many can I fit in the middle? I can fit 1 square unit, okay, 1 square unit. If I have a 2 by 2, okay, side length 2, okay, it's s squared, so that's 2 squared, that equals 4, and that actually matches up with what our observation is. We have 1, 2, 3, 4 square units. 3 by 3, well, sure as heck, you see it right here, okay, 9, right, 3 squared, okay, s squared, 3 squared equals 9 is your area. So this is our assumption, okay, because we can observe this, right? It's made through observation, but again, can we deduce it from other pre-existing postulates definitions? No, area is a brand new thing. Area is a brand new thing, okay? Area, of course, is what's bounded inside a particular figure within one plane, right? Within one plane here, okay? Surface area could be multiple planes, but you add up all the different planes that get taken care of in other shapes. Okay, there it is. Area of a square, area equals s squared. And this is going to build into the next one that I talked about last class, which is area of a rectangle. So we're going to use this postulate 17 here, that area equals s squared, to prove that the area of a rectangle needs to be the product of its base times by height. That one's coming up next on this playlist. So watch with me.